starting here. Okay, how are you today?
I'm fine, sir.
Fine,
Okay,
sir. Thank you.
that's really good. Yeah, before we start the meeting, I have an announcement. You can call me Agung or Mas Agung. Okay, normally my student will call me as Agung or Mas Agung. So I think there is no difference between all of you with my students. Okay. The next one is can you hear me? Can you hear my voice clearly, or do I need to change my connection there?
Yes, sir. It's clear.
Okay, so it's already clear, right? Okay. Well, we will wait around 9 o'clock, right? For operation, I think I can share my screen, so therefore you will be able to see what I see in my in my monitors. Okay. For the facilitator, is there any Mbak Bila or?
Yes, Mas Agung.
Oh, okay. So you're already here. Okay. So what shall we do now, Mbak Bila?
Yeah, sorry.
What shall we do now? Can I start my presentation or?
Yes, please just start the presentation.
Oh, okay. Thank you very much. Okay. Good morning, everyone. My name is Agung Tatoibowo. So I'm a magician in here. I love to play with snow. Yeah, doing some magic trick, to be honest. No. I'm a lecturer. So I'm a lecturer at Telkom University. It's starting from, I think it's 2006, perhaps. Yeah. I remember that when I start my lectures in Telkom University, it's around 2 of January. So basically, I can enter Telkom University at 1 January, but it's not open. So I start at 2 January. My latest work is definitely I do a lot of work to be honest. For example, like before my bachelor of informatics in at Telkom University on 2003 until 2005, I was a programmer making a finance program at Samudra Aplikasi Indonesia, and still those CV CV Samudra Aplikasi Indonesia is still exists now, and still focusing on the finance applications. But then after 2003, I stopped since doing such programming and kind of things make me drop my EPK, okay, and then I stopped my job, and then looking for another money when I see my tabungan is still I have only $1 million, $1 million, not $1 million, 1 million rupees only for a couple of months. So I need another job. I do a couple of jobs as a programmer in there. I continue my master degree around 2007, and currently, at 2016, I have a PhD in computing science at the University of Aberdeen. It's a quite a good place. It's at Scotland. Yeah, it's Scotland, United Kingdom, and it's a really nice place to go. So if you would like to know more about my background, you can go to my blog, agungtoto.web.id. Yeah, basically I push a couple of things in there. This is the my university, and and so on. Yeah, okay. So currently, I'm not as only a lecturer, so I'm a gardener, to be honest. So if you come to my house, you will see a couple of orchid plants. And today I will also share machine learning things related to my hobbies. Okay, so hopefully you can enjoy for my later demonstration in the end of our meetings. Okay, so I think this is common in Bangkit. You already see this slide often. Our ground rules are please give full attention in our class since you are here to learn something, especially related to TensorFlow as well as machine learning. Okay, so don't waste your time. So please give full attention in our class and then mute your microphone when you are not talking. For example, when you are listening something, ensure that there is no iklan around us. For example, like tahu bulat or those kind of songs that exist in around our neighborhood. So please mute your microphone in there and keep your camera on if you are in a good position. I meant in a good bandwidth. Just put your camera on so it will give me a feeling that oh yeah, I'm not talking only on this machine, so I'm talking to people. I can see Mas Vincent, Mas Budi, and so on. So yeah, please turn on your camera. And then it's an optional. My English is not good enough, so therefore perhaps the what is it, the CC features will help you to understand what my talk about. So especially when I hard to find some vocabularies in English to explain everything's in there. And then the fifth one is please use raise hand or a chat. I think we have a question answers, but Bila, or we are using the chat in here. We are using question and answer or to ask questions. Yeah, there is a
Yes.
question and answer function in Google Meet, so you can use that. I think for later on, we can discuss those questions in the end of our lectures in here. Hopefully, you can write down your questions before you forgot those questions. Okay, when you already notice that I need to clearly I need to have this answer, so you can put a question in there, and then make this room as a safe place to learn and share. I'm not the one who teach in here. I also learn from you, especially when you are know something that I perhaps didn't know those things. Okay, so you can share many things as you like in here. Okay, but make sure that it's a safe place for everyone. Don't use difficult words. I meant the one that makes everyone's heard or those hate speech and so on. Okay, I think that's the thing in here, and I think for the next one, before we continue our sessions today, I will give Mbak Bila to conduct a quiz. Is it correct, Mbak Bila?
Yes.
Okay,
Mas
so
Agung,
the
thank
time
you.
is yours, Mbak Bila. Okay.
Yeah. Okay, so guys, so we will do the quiz in the beginning of the class. So please go to your decoding or just click this link on the check box. You have 10 minutes to do that. Starts now and should be finished at least at 9 past 17. So yeah, please go to your decoding account. We will wait until 9 past 17.
Okay. Thank you, Mbak Bila.
Yeah, all right, the time is up. Mas Agung, you can continue your presentation. Thank you.
Yeah, okay. Thank you very much, Mbak Pila. I think the problem by turning off the microphone, usually people forgot to open those microphone before talking. Okay, I'm using my what is it, headset now. It's different from the previous one. Can you hear my voice clearly?
Yes, sir.
Oh, okay.
There is no problem.
Okay, thank you very much. So today we will talk about these things. The first one is we will introduce you to the machine learning as well as into the deep learning. I assume that you already know about machine learning as well as the deep learning as well as the deep learning. In the previous talk, I think the one who present already what is it, explain this phenomena, but hopefully you can have something coming from my explanation, or at least by repeating this terminology will what is it, strengthen your memories about the machine learning as well as the deep learning. And then the second one, for the third one, we will talk about the convolutional neural network. It's kind of like an operation or filtering something or creating features based on convolutional operations. It's kind of like an image operation, to be honest. It's simple. However, we will do a stack using the neural network. I think it's a part of a machine learning algorithm there. And then using another talk, we will talk about the natural language processing, which will process the human language in terms of a text, not in a voice in there. And then we will also talk about the time series data, how to create a regression using the machine learning algorithm. In the end, we will have a performance evaluation as well as the sharing session, and hopefully we will have a fruitful discussion on today's agenda. So, firstly, about the machine learning. So, before the machine learning become popular, normally people will create kind like rules to define something. For example, like okay, if the face is tirus and then the skin is white and then the hair is not bald as me, so those people are handsome. Okay, so those kind of rules normally are created by human. Okay, since the human is the one who create a program, in our traditional programming paradigm, those kind of rules are coded into a program. For example, like in here in this illustration, when the speed is around 4 kilometers an hour, then we can say that yeah, those people are those person are walking, is walking. Okay, and what we have in here is, firstly, there are two input in our traditional programming. The first is the data itself, and then the second one, we need to define the rules, and then we can decide something. Okay, and if we would like to increase our case, for example, like yeah, the activity they are working, they are running. So since the running is higher, having higher speed, we can say that that we have an else statement in there. Well, the status is running. It's not having the speed is less than 4 kilometers an hour. So it's higher than 4 kilometers an hours in there. So still, those kind of things, we have the rules. For example, like taking the handsome or not, perhaps, yeah, it's not bald. However, it's didn't use proper clothes. Then we didn't say that this person is handsome. Okay, so we have another rules in there. It's not my type. Sometimes we say like that. It's also a kind of like the old traditional programming. And then if we would like to add another criteria, so the answer in here is kind of like decided things, or the lab in our machine learning things, we will call it as a label in there. Okay, the status of those data is working or running or biking, it's depend on our rules in there. Talking about some applications, normally in banking application, for example, we know that in banking there are credit status for persons. Okay, we can reject or accept a loan from a person based on their history. For example, like how many income they have, and then how many they spend their money monthly, or many things, many data that we can provide to bank, and then the bank will decide whether our loan are approved or disapproved. Okay, so that's using this kind of case. We can also create another programming paradigm, which is using traditional programming. We can decide if the money, what is it, the income minus the number of people spend monthly is larger than these numbers, then it is okay. Or if the, what is it, the age is higher than 40, it's not okay to give them money. Okay, so we can also do in different cases as well. However, sometimes we have another activities which is didn't observable using our rules. Okay, so using those kind of things, if we do a traditional programming in here, if we know a phenomenon, for example, like in a banking, we know one phenomenon, then we need to change our program or our software day by day, and it's very hard. It's really hard task to do this, since well, in banking or in another online or another online application, it's really hard to update. Update is not a kind like something that we can do every day or every times that we have. The other things that another paradigm that we have in here is using the machine learning. So what is the machine learning? To be honest, the machine learning and as well as the programming, traditional programming, is still a kind like a program. Okay, so what in here in our machine learning is still an algorithm. However, the difference between the traditional with the machine learning paradigm is we have the data as well as the answers. Okay, so we have a couple of tuple. If this data, then the answer is running. If this data, the answer is biking. If this data, then the answer is walking. We have a lot of data like that, a pair of data and answers, and then using an algorithm in here, we can have many algorithms in there. We can extract rules. Okay, what we extract is our rules. Normally, we decide if the people is handsome, if the people is not handsome, using our own rules. Okay, so in machine learning, we will extract that rules. So basically, we didn't do anything about the rules. The rule is our output, and then for later on, if we have a new data without knowing the answers, we can use those rules by using the machine learning algorithm to decide the answers. Okay, for example, like there is a new students or there is a new people arrive to our in front of us, then we can say that having our previous examples, having our previous knowledge, we have this kind of rules. Then those new students is handsome, those new people is ugly, or those kind of things. Okay, so what is a machine learning? I think we don't directly express what kind of machine learning in here. What we have in here is a kind of like a situation or an examples. For example, like in the house price predictions. Okay, so when we have a property of a house which is sold by people, then we can estimate how many number we need to sell those house. How is the price? How much price shall we give to peoples in there? So the first one is in here using the traditional one. We need to have the base price. For example, like a base price or the average price, perhaps the average price in a location or in a city is perhaps around 400 million rupiahs. Okay, so that's the base price. And then the second one is, I think we need to calculate how many number of bedrooms, or perhaps in Indonesia, normally we have how large the land is, how large the building is, and so on. How many bedroom and how many living rooms in there, and so on. Okay, so using the traditional one, we need to have some kind of like those rules, and those rules are need to be coded by the programmer as well as extracted by the expert in there. So we need two people in there. However, using machine learning paradigm, we don't need to extract those rules. Okay, what we need to do is just checklist our attributes in here as our input. Okay, and then we have another attribute which is we will call it as our target in there, or class label if we are in a classification form. Our class label is the price that sold in our history. Okay, for example, like I own a company. Okay, I own a company. My company uh, sell the house from 2000 and 2001. Okay, so from 2001 until now 2020, perhaps there are a lot of transaction that we have. Okay, so 3 bedroom, 1 bathroom with the years built is around 1812. Then the price is this amount, and then perhaps I can add another one which is the transaction year, and so on, is this amount. So, okay, so having this transactional data, we can learn, we can create an algorithm which learn from our data. So what we learn in here is the data itself. Okay, we will extract a rules coming from this data to create or to predict things. Okay, that's what happened in the machine learning. Based on those illustrations, perhaps we can compare the rule-based versus the machine learning one. The first is for the rule-based, normally we have a human or a programmer to develop the logic flow. However, for the rules itself, the if-then rules, we need an expert or perhaps more than one experts to define the rules. Okay, and normally the rules are changed over times. Okay, for example, like the housing price on 2018 with 2020 and 2022, perhaps they are changed. Okay, so using that kind of thing, so perhaps we will have another, what is it, a drawback of those paradigm. The one is we will have limited to human reasonings. Okay, perhaps the one who create the rules, if we have Mas Budi and then Mas Ghazali create the same rules to solve a problem, perhaps the rules will be different from one expert to another expert. Okay, then we will have a limitation to human reason, as well as the exposed bias to the implementator as well. Okay, so the expert explain to the programmer, however, the programmer might implement something different in that. Okay, so that's happened in the rule-based, as well as the one that I mentioned that is not in here are the time or the rule, perhaps for a temporal aspect in there will be changed in during the time. And then the versa of the rule-based or the traditional one is using the machine learning. In our machine learning, what we need in here is a bunch of data, a lot of data. So our algorithm, we will say in here, is our model. will be trained with our data. Okay, so the data in here can be a transactional log using information system exists in the the company. Okay, so when we have a lot of data, then we need to extract a pattern using some algorithm. For example, like using naive Bayes, then we will see the probability of a kind of data over the target. The target itself is can be different among the case itself. For example, like when I would like to define the case, then for example, like a COVID case, so that's the target is our COVID case. If I play with a stock market, then the next price will be our next data or our target data. If I would like to say to the Bangkit Academy or in Telkom University, they are pass or fail student or having grade A, B, C, D, that's also our target. So using that kind of data, we need to learn from those data, and then we need to create an experiment. Okay, perhaps when we start our model, it will produce a very non-accurate algorithm or non-accurate model. However, if we learn another one, train those algorithm in a couple of iterations, then the accuracy can be increased from one iteration to another iterations. And then having for this kind of things, the one that if we compare to the rule based, the model itself is the if then rules which is created by the expert. However, in here, perhaps the experts, we don't need any expert at all, just the data and then our algorithm in there, then train our model. However, the machine learning itself also have a drawback. For example, like the one in here mentioned in here is it's limited to our training data set. Okay, so basically, if we have different data, okay, for example, like a stock market, there are a telecom company stock market as well as a telecom cell stock market or Indosat stock market. Even though three of them are still in talking in telecommunication company, however, the price of telecom company might be different. The movement of the stock exchange in there can be different. Okay. Another example is perhaps using the student grade. Okay. We have the UTS, UAS, and then quiz, tugas, that kind of data as our attributes. Okay, and then if we applied our data to machine learning courses and the Android courses, perhaps it's also different. So saying that with that situation, we can say that the machine learning things, we will need to train or create another model when we have a new data. Okay, that's the drawback of our machine learning. And then the last one is expose the bias of the training data. Okay, so normally when we deal with machine learning, we will divide our data into the training set as well as the test set. When we wrongly select the training data set, then it will resulting differently. Okay, so it's kind of like not generalization for the whole things. So this is the difference between rule-based as well as the machine learning. Now we will see what machine learning can do. There are tasks that are solvable or can be solved by the machine learning. Our first task is called as a classification. So basically, we can have a data. It is an illustration or a visualization for our data. If we have two-dimensional data, for we have a y coordinate as well as the x coordinate, and then we have a data in here. label it as green, and then another data in here having y is equal to perhaps 1, and then the x is equal to 3, then it's labeled with yellow, and so on. Then we can create a rules that classify, okay, you are green and you are yellow. Okay. If we see the other cases that can be solved by a classification problem, we have something like, for example, like COVID cases also. Oh yeah, you are a positive, having positive COVID, or you are negative to COVID, using this kind of attribute. Or perhaps if we set to our another cases in the our university class, you are passed to that subject, you didn't pass to that subject, it's also a kind of classifications as well. So the next task is regressions. In our regressions, what we face in here is not a kind like labeled data. What we face in here is predicting a number to be as a function of an attribute. For example, like when we have the input is one attribute in here, for example, like an x. This is the x is equal to 1. Then we will predict how many values in here. Okay. In our previous example, we have the housing price. Okay, the housing price is not a classification. If we say about the classification, perhaps it's a cheap house, or what is it? Rumah mahal ataupun rumah yang murah. That's a prediction or classification task. Okay. However, the regression always output as a number. Okay, always output as a number. For example, like okay, I have this data. Using this kind of regressions, I will say that those data will be this output. Okay, we will put a number in there. If we talk about the classification, normally it's kind of like a categorical data. A, B, C, D is a categorical data. Pass or fail is a categorical data. However, for the regression itself, it's not a categorical data. The output itself is numerical data, so we will output values in there. Another example is perhaps for the stock exchange or the currency exchange. Okay, how many rupiahs we can obtain from a dollar today, or how many rupiahs that we can obtain for tomorrow or another day. Okay, that's also a regression task. Okay, so another things that we have in here, what machine learning can do is clustering. Okay, so it is different with our previous two examples or two tasks. In clustering, what we need to do is create a group of data to segment those data. Okay, for example, like when we have these dots, many dots, we can say that this one become a group or become a cluster. Okay, we can call it, or for later on we can create a label as a yellow cluster. And then for later on, since those data is close once each other, it's also another data. Okay, sorry, another cluster, and then we will have another cluster in there. Okay, so in our real world, perhaps we will have a segmented market. For example, like okay, when we create a new product, we would like to normally we would like to create a segmentation of our customers. Okay, okay, this customer, this having this age, having this what is it in this city, having this how many child, how many many data in there, and then we can cluster those data. Okay, it's kind of like a more clustering one. Okay, so having this cluster, so we can say that we can use it for later on. For example, like when we would like to launch a new product, we can ask to this cluster whether our product are good or not good. we can ask to this cluster whether those products are good or not good, and then we can ask to this cluster whether that's good or not good. And then for later on, we can perhaps provide some discount, or perhaps some marketing strategy related to specific clusters, okay, or specific customers. Okay, so that's what we can do in machine learning. We also have many things that we have in machine learning. However, for an introduction, I think that's three are the major topic that discussed by people. If you would like to read many things regarding to the what machine learning can do, you can also read about the autoencoders, or perhaps another thing that we can have is explanatory algorithm, explanatory machine learning algorithm. I think you can read for later on. Okay, so the next one, I think it's also important for us is predicting a sequence. Okay, so basically it's kind of like a pattern in a sequence events. Okay, if they are green followed by yellow followed by orange followed by green, so what is the next data? In our pattern, we have this one is yellow. Okay, the yellow is having higher probability compared to the other colors. Okay, so having this one, so what's those data? So it's kind of like sequence applications. The sequence itself can be what is it? We can have kind of like tasks for a sequence. For example, like if I do mandi, and then I change my clothes, and then I walk walking through my neighborhood, and then go back to my house. What is my next activity? We can also create something like that. Or perhaps in another examples in gaming tools, if we have many actions in an actor, for example, like kicking, punching, and then special what is jurus special? I don't know the English for jurus. Kicking, punching, and then jurus 1, jurus 2. What's the next action? Okay, so it's also happen in our daily life. So that's what machine learning can do. Continuing to the deep learning, to be honest, the deep learning is also a machine learning. It's part of the artificial intelligence. In our broad terminology, we will have the artificial intelligence in there. The artificial intelligence involving many things. For example, like we have a pathfinding. If you use Google, asking Google Map to provide a solutions, which direction so I go from Telkom University to a specific place, for example, like to Alun-Alun, or going to Gedung Sate. So there is a best route in there. So it's also in an artificial intelligence applications. Another thing, perhaps reasoning and so on. And a more specific terminology which is in the artificial intelligence is the machine learning. We have mentioned before that the machine learning is learned from the data. Okay, so we need a bunch of collection of data in here. And then about the deep learning, since it's a subset of machine learning, we still also need a couple of data, a lot of data in there. It's kind of like a specialized algorithm for deep learning. Another class outside the deep learning, but still in the machine learning, perhaps we will having shallow learning. Okay, shallow learning such as k-means, k-nearest neighbor, and so on. That's are in the shallow machine learning. Okay, so we have a terminology of deep learning in there. Why deep? The answer about the deep itself is coming from the first thing is we need to know about the artificial intelligence. However, before I explain about the artificial intelligence, I would like to answer why it's called as a deep learning. Okay, so the deep in there is related to how many layers in the artificial neural network like. Okay, so when we say that our layers is larger than 2, okay, we can say that that is a deep learning. Even though it's an artificial neural network, we can say that that is a deep learning. Okay, so what is artificial neural network then? Okay, the artificial neural network in here defined as a computational network inspired by the function of human brain. You know that our brain have a kind like we call it as a neuron. Okay, our information coming from our sensory can be skin or our nose, our lips, our ears, our eyes, and so on. That is a sensory data. Using those sensory data, we put those sensory data as our input in here. Okay, and then we will transmit those data to our brain. Okay, so the this is the our brain brain like or inspired by our brain. Our input will be processed using our brain. Therefore, we will provide an output in there. The output itself can be different. For example, like okay, it's too loud. Then perhaps I can reflect to open the headset in here. Or if it is too loud, then you can close your eyes or many things. Okay, so since it's inspired by the human brains, if you see our brain, the neuron itself are connected to another neurons. Okay, one neurons can be connected to another neurons, and then it can also connected to another neurons having different layers. When we have the layer is larger compared to 2, then we can call it as a deep learning itself. Okay, so the next question perhaps what happened in within the neuron itself. Okay, so to be honest, we didn't know what happened in our brain. However, in the artificial neural network, this is the one that happened in our neurons. Okay, so we have a data in here. Okay, to be honest, it's kind of like a number. Okay, when we have a number, we can multiply with a specific weight related to those input connected to neurons. Okay, when we multiply every input with its weight, okay, then we create a summation of this and create an addition with a bias. Then we will have some summation function in there. Okay, so basically on the summation function in here is kind of like mimicking our idea that I believe those data with a specific weight. I'm lower believe those data compared to the previous input. Okay, I highly believe those data compared to the previous input. So the weight in there is representing a kind of like a priority, which multiplied to our number in here. So we will add every multiplication of our input with weight, and then pass our summation function into a kind of like an activation functions. Okay, the activation function in here will be changed our number in there into different informations. Okay, when we have another informations, then we can propagate to another neuron or propagate to another layers. That's what happened in the neural network. I think it will be better for me to stop my explanations. If you have some question, perhaps you can ask in the question and answer. Do we have a question in the question and answer tab, Mbak Bila?
Yes, we have some question.
Oh, okay. So I'm opening those question. The first question, I think it's coming from Mas Budi. What a common mistake can make our model outfit or underfit? Okay, so for the overfitting and underfitting, I think it's better for us to discuss these things on the later on slide, since we haven't talked about the overfit as well as the underfitting. So I do apologize for it, Mas Budi. And then the second one, is there a good way to design cross-validate model in TensorFlow, since this is easy to implement in scikit-learn, also reproducing is setting. Okay, so in TensorFlow, thank you very much. The question from Mas Hapsoro Abioso. I think there are solutions for it if you do a cross validations TensorFlow. Okay, there are a bunch of what is it? An illustration or a tutorials in there, Mas Kunchoro, and as well as the previous question. I think it's better for us to discuss for later on. For example, like in here, we can use the similar to the scikit-learn model. Okay, we can create a k-fold cross-validation as well to create a test to split the training and testing model, Mas Kunchoro. Sorry, Mas Abioso. So I hope that's answered those your question. And again, we haven't explained about these things, but yeah, I think you already know about it. Why we don't need to put a label encoder or another encoder before training data in TensorFlow? Is there any include encoder inside the TensorFlow, then automatically encode when we start the training our model in TensorFlow? I do apologize, Mas Budi. Can you explain your question, please? For the second one.
I have experience to build machine learning in with sklearn.
Okay.
So before the training data, before splitting data, I must encode the data like misalkan ya Pak, Bandung, Jakarta sama Bali.
Okay.
Bandung is 0, Jakarta is 1, and Bali is 2. So we can training our model dan mendapatkan hasilnya gitu.
Okay. So basically in TensorFlow, what we have in here also similar to the one that you do, Mas Budi. I think for later on, it's we have a discussion about natural language processing. So in there, we also need to encode our words Bandung as our first vocabulary, Jakarta as our second vocabulary, and so on. That's also happened in here. To be honest, the TensorFlow is an artificial neural network like we can say like that. Since the artificial neural network is having the numerical as our input, so we need to change everything which is not a number become a number. So that's, I think it's also related to your question, Mas Budi. Yeah, but we can discuss later on. Yeah, for it. Okay, I think we have three questions, and it's I'm very impressed that it's not like a basic one. So shall we skip in here, or we can continue to our discussions? Okay, let me continue my slide in here. This is the slide that Bangkit already provided for me to present to all of you. Okay, so how to build the neural network models? I think if you would like to implement the neural network itself from scratch, by means that you need to multiply this number with a certain weight, and then summing that weight, and then put into activation function. You can do that as well. Okay. However, if you would like to go back to this kind like architectures, we have layers. we have another layers, in there, then it's not easy for you to implement from scratch. Okay. However, currently today we have a TensorFlow. So using this TensorFlow, you can create an easy way to build a neural network model. Okay. So what's in the TensorFlow in here? They support the distributed computing. So when you have a very complex calculation, I think it's better for you to distribute the computational in there. And then if you would like to running using GPU or a TPU, it's also supported by the TensorFlow, and yeah, it's more easy compared to if you would like to implement it from scratch. In here, I have a playground. We have a playground in TensorFlow in terms of if you are new in machine learning or if you are new in a neural network. We have a collection of data in here. As you can see that we have many points in there. I don't know how many numbers, how many data that we have in here. Plotting to these points, we know that there are outer layers labeled as yellow labels in there, and then the inner layers or the core data, which is labeled with the blue ones in there. If I can model using one hidden layer as well as one neuron in here, accepting the X and X1 and X2. So X1 is that one, and then X2 is that one. Okay. So if I would like to train these models, okay, so basically it's kind of like a model. We have this input multiplied by a certain weight. Okay, we have a certain weight, and then passing those information to specific neurons. Okay, and then we can create something which is decide whether they are blue or yellow. As you can see that in here, our model is unable to separate between yellow and blue data in there. We can add another neurons in one layers, or if you would like also, you can add another layer as well. So if I add another neurons, then I train my models. It's giving me some kind like this. Even though previously the yellow one are still misclassified. However, compared to the previous one, the misclassified data in here are lesser compared to the previous one. Not only adding the neurons, we can also add another layer if you like. I think it's enough with using two layers. I guess so. Let's see. Okay. So still we are unable to find a solutions. Perhaps we can do something like this. Okay, so basically it's already classified our data smoothly compared to using only the previous architectures. We can call it as how many neurons and how many layers. The combination of how many neurons and how many layers in there is as an architectures. Different shape of neurons, different number of neurons, even though it's within the similar number of layers, we can still say that that's also different architectures. The one that perhaps not an easy task for us is to define the correct architecture for our data. Okay, so that's what happened in the TensorFlow playground. You can search using playground and TensorFlow keyword in Google to find those websites. So what can deep learning do? I think it's kind of like an advanced application for the deep learning, and yet it's still useful for us to know, and hopefully someone can be developed and applied this technology in Indonesia to support our governments. Okay, so we will see what's happened in the following
Hello,
videos.
my name is Alejandra.
And I'm Erickson.
And we're using machine learning to find potholes on the streets of Los Angeles.
LA has over 7,400 miles of roads and freeways.
That's a lot of roads and a lot of potholes to fix.
Right now, construction workers have to manually inspect roads for dangerous potholes and cracks, or rely on people calling in tips, which takes a lot of time.
While studying at LMU, we started to see if we could figure out a faster way to identify potholes throughout the city.
First, we needed data. So we rigged a camera to a car and we drove around to capture footage of different roads and freeways.
Then, we used Tensorflow, Google's open source machine learning tool, to develop a model that could quickly identify potholes, road cracks, and other weird stuff with a high rate of accuracy. Which means workers can spend less time finding potholes and more time fixing them.
Okay, so I think that's another applications that we can have in using the deep learning. However, it's not limited to that application. If you search the application Tensorflow examples, there are a bunch of applications that you can see at. Okay, there is image classification, pose estimation, speech recognition, and so on. So I think if you focus on one thing in here and having a brilliant idea, I think the one that in our previous video is a very brilliant idea implemented in real world application, and it's yet very useful. Okay, so if you can search for a very useful idea, I think that's a good proposal for your project, for letter project. Okay, I think since your questions already in advanced mode, let me continue the whole things, and then we can discuss your question later on. For the convolutional neural network, the convolutional neural network is a kind like deep learning type. Okay, what we use in here is convolutional operations. So basically, a convolutional operation is an image operations or a matrix operations normally applied to an image. Using those convolutions, we will transform a data to another data. Okay, transform a data into another data. If you play Instagram, when you use a filter or many kind like those operations, it's also a convolutional operations, to be honest. Okay, you can skew things or detect a face or so on. That's also a convolutional operations. In the convolutional operation neural network, which is we can call it as a neural network like, which involve a convolutional operations. What we have in convolutional neural network, we have convolutional operations, we have max-pool operations, we have another convolutional operation, and so on. And then we have a flattened operations in here. And then we will add a neural network or fully connected neural network base or artificial neural network base like in there to classify something. So basically, what happened in convolutional neural network in here, we will select a kind like features, okay, feature space on the following image. If you read papers, on 2000 lower than 2000, normally what people do is the artificial neural network with the convolutional operations are separated to the neural network. Okay. However, in the convolutional neural network, we can operate the convolutional neural network to our image to find some patterns. Okay. For example, like we can find an edge in here. a horizontal edge, a vertical edge, and so on our first convolutions. And then combining the vertical, horizontal, and so on operations, we can create another convolution to create an intermediary features, and then we can create another higher features. To be honest, what happened in convolutional neural network is kind of like automatically creation of features based on an image. So that's what happened in the convolutional neural network. On its convolutional layers, if you already seen about the neuron in artificial intelligence is artificial neural network is multiplication and then summation and change into a specific function. However, in the convolutional neural network, the convolutional layer is kind of like multiplying our data, which is an image like, using a using a filter, a specific features. We can create these features or different filter as well. For example, like when we having this one, the first column, this one, the first row is all 1, the second rows is all 0, and then the third rows is all -1. That will be different features compared to this one. Okay, so what we do in here is multiply the if sorry, I cannot stop this slide. The first element of the gray shape with the first element of our features, the second element, the third element to the second and the third element. So therefore we will have this data. Okay, and then we can multiply to another data as well. Okay, so you add the whole things in there and then put into a new values. As you can see in here that we will transform our input into different output. Okay, so basically what convolutional do is we will change our data into a specific output, or we can say that we will detect whether the following features exist or not exist. For later on, we can create a pooling layer. For example, like selecting which maximum values or which how many average values that we have in there. For the pooling layer, we will call it as a downsampling, since what we do in here is ignoring some information, however, still maintaining to another information. For example, like when we use max pooling, operate on these cells, the green cells, then we will ignore the 9, 5, and 11 data in there and still maintain the maximum values on this data. We can use many pooling operations. For example, in here we have the max pooling as well as the average pooling. The goal on the pooling layer in here is trying to reduce the size itself. For example, like in here, coming from 4 multiplied by 4 matrix, we will have 2 multiplied by 2 matrix. So the data will be decreased. However, the information itself still we maintain the information using these operations. This is the natural language processing. I think Mas Budi already learned about it. So what is the NLP? The NLP is a branch of artificial intelligence that give machine ability to read or understand. Okay, to understand in here it's not read using a voice. However, it's read the semantic meaning of the text itself. For example, like reading. Okay, read. We can use for later on application, for like Google Translate read into a different word. Okay, when we combine using different words, then it also have a different semantic meaning. Okay, so that's what happened in the natural language processing. The natural language in here, in terms of our language, our human language, we process our human language using the artificial intelligence machine. Especially in here, we will use the deep learning in there. I think this one is Mas Budi's question previously. How the computer process text. We know that there are each word we can have a different length of word. Love with I will be different. Love with my also different length in there. What we doing here is encode this word into a kind of like a dictionary. Okay. Normally, we will create a dictionary based on our data set. So, for example, like I have a bunch collection of article in DBC, then I will collect those and then what is it? Give an alphabetical we can sort or not sort the word in there, and then change using a dictionary. For example, like the I in there, we will change into one numbers. Love, we can change into two, and so on. And then when we have I love my cat in there, I can change those sequence into 1, 2, 3, and 4. Therefore, if there exists my cat love I, not love me, or love I, then we will have 3, 4, 2, 1 as our data. As you can see that we change our text into a number. Since this is a number, we can continue to our machine learning techniques. The important process in the NLP, there are a couple of process. Normally, we will have a tokenizers. The tokenizer will be factorize our text into and change into an integers. Okay, using a specific dictionary. You can also follow it by the text to sequence, which is transform each text into a sequence of integers. I think in the previous examples, you already seen the example of the text to sequence. We have a sequence of a number in there. And then don't forget, if you use the NLP to put the out of vocabulary dictionary. So therefore, what you do is you just put a special values when you have an unseen word encountered in our data. Okay, for example, like wk, that's not in our dictionary. So we put those data or the out of vocabulary. We can also add another process, for example, like stemming, which is a specific what is it? A specific term of tokenizers. Okay, for example, like I can have berlari. Okay, we can create the root word of berlari into lari. Okay, so we will change, remove the imbuhan ber, and then having the root word is lari. So that's also happened in the natural language processing. Another process that we have in natural language processing is the stop word removal. We will remove a non-important word. For example, like in this sentence, perhaps we can discard off in there. We can discard in, and so on. Okay, if we consider in, off, and those words are not important in our dictionary. And then the one that we can use in the natural language processing is the padding. Padding is used to fit all dictionaries in one sequence. So all sequence have the same length. This is the goal of the padding. Okay, so this is the example. If I have two sentences in here, you know that the length of those sentences are different. I have the first sentence and then the second sentence. I can tokenize and then create a sequence of this sentence. Okay, I have this dictionary and then put the sequence in there, and then we can create a padding, which is in a sense of our deep learning algorithm or our neural network algorithm base need a constant number of inputs, similar number of inputs. Therefore, we create the same length using the padding operations in there. So using this padding, we can use at 0, 0 in there, or if we have longer words, then perhaps we can discard a couple of sentences or a couple of words that appears in our sentence. And then we can also use word embeddings. If you use a word embedding, it's normally convert the words into different dimensions. Okay, there are a couple of algorithms, such as you can use a word to fact algorithm to convert your word into a vector. So for example, like in here, we have three-dimensional vectors. The Honolulu, what is it? The cities are placed in a group of area. Meanwhile, for another term, perhaps it will be placed in a different area as well. So the word embedding in there can be embedded in what Mas Budi already mentioned in his question, or using a specific algorithm, for example, like a word to fact. Okay, so that's what happened in the natural language processing. I think I already talked around 47 minutes and still counting. Another explanations that we will deliver today is the time series data. What is time series? I will be quicker than before. The time series in here is an ordered sequence of values that are usually equally spaced over time. Yeah. Okay. There are many data which is in a form of time series data. For example, like if you measure the temperatures this hour, the next hour, on an hourly basis, then you put that into a chart like this, that then we will have a time series data. Okay, you can collect a year's data, hourly based data in 1 year or in 2 years, then you will have a time series data in there. Stock market as well, the price in there, weather forecast, historical trend, and so on. It's also in a time series data. You can use univariate or multivariate time series. If your data is only in one variables, then we will call it as a univariate. If your data is in the multi-variables, then you will call it as multivariate data. For example, like this is the price, the oil price. Okay, so we have oil price. We can compare to the gold price. Okay, or so on. So we have many data still in the series things. Then that's it's depend on our input. We have univariate or multivariate. Normally, the gold with the stock markets, it's kind of like a very different habit. If the stock is going up, then the gold price is going down. If the stock is going down, then the gold going up, and so on. So it's kind of like a multivariate application for this time series data. And then if you use the multivariate or univariate data into a time series, then what you need to do is a windowing data. Okay, so basically you put a point in there, and then you move forward how many steps. For example, like from well, I measure my temperatures in hourly basis, right? In our previous examples. So using the windowing, if let's say if I start from 8 hours, from 8 o'clock, then if we use 5, then 8, 9, 10, 11, and 12, that's a data. Okay, one row of data. And then we can use another data, which is 9, coming from 9, 10, 11, 12, and 1. Okay, that's another data. So we can move our window using the fixed length window in there to obtain a specific data. By doing so, since we already having padding-like operations, we can put our data into the machine learning algorithm. And then when you dealing with machine learning algorithm, normally we will evaluate our algorithm whether it's resulting a good performance on or bad performance. And we have a couple of performance evaluation in here. The first one is the accuracy. The accuracy in here is calculated by calculating how many true positive adding by true negative, so true positive plus true negative compared to the whole data that we have. What is the true positive in here? The positive in here is we know that we have the actual data. For example, like the actual cases of COVID. Okay, the actual past students or the actual that's we call it as the positive one. When we predict as positive, the actual positive COVID, and then when we predict as positive, then we will call it as true positive. If we have 1,000 positive data, then and it's all predict as true positive data or as a positive COVID, then we have this number of data. That's the number of true positive. Meanwhile, for the true negative, if we have a non-COVID patient or the negative COVID in there, and then we predict as negative as well, the prediction and the actual values is similar or match in there, then we can have a true negative in there. So when we calculate the number of true positive plus true negative compared to the whole data, okay, compared to the whole data, we can call it as the accuracy. And then the second one is the precision. I forgot which one is the precision or which one is the recall. Okay, so both of these you can search in the internet. I think the precision is can be seen on the actual positive, or so the true positive added by the false negative compared to the whole data, and then for the recall is the true positive added by the false negative compared to the whole data. I think that's the equations. But you can search on the what is it, the internet formula. Okay. Okay, the precision is the true positive. Oh, sorry, the true positive compared to the true positive plus false positive. So the precision is only on the positive one. Meanwhile, for the recall is on the true positive on the false negative. So yeah. Okay, so the recall is the true positive compared to the true positive plus false negative. So that's the recall. These values compared to that values. That's the precision. The recall is the true positive compared to that values. That the recall and precision. And for the F1 score, it's a combination of the recall and precisions, and you can search in the internet. I think the internet knows better rather than me. But yeah, I can read that formula if the formula appears on my in my eyes. Okay, so the second one that's for the performance measurement for the classifications. If we deals with the regressions or the time series data, which output the a number, then what we can use for measuring our performance is this formula. The first one is the error, which is will compare our forecasting compared to our actual data. For example, like we forecast tomorrow is 100. However, the actual data is 99. Then there are error exists, appears one error. Okay, if our forecasting in here is 1,000, Okay, and our actual data is 900, then it's appear 100 errors in there. Meanwhile, for the next one is the MSE. We will square our error, and then having finding the means in there. So we will sum the whole error for the first data, the second data, the third data, and so on, and then square it to discard the negative values in there, and then trying to find the average value of the square errors. That's what appears in the MSE. Meanwhile, for the RMSE, we need to square root the MSE. The MAE, we didn't use the square, but we used the absolute values of our error. For the mean absolute percentage error, we compare to our data. Okay, if we have the error is equal to 1, I think it's small values compared to 100. Okay. However, if we have our error is 1 as well, however our original value is 10, it's larger compared to the previous example. So that's what happened in the MAP. Okay, I think that's one on the our discussion, and I'm sure we have a bunch of question and answer. I haven't answered the whole question. So what's a common mistake can make our model overfit or underfit? Oh yeah, I haven't explained about that one. Okay, so yeah, so many slides in here. I forgot I put some overfit or underfit or not in here. Oh no. So so what is overfitting? So the overfitting in there is a situations when our model learns something and it's mimicking on our training data set. Okay. For example, like I have this collection of data set. Okay, 1, 2, 3, and 4. And then if I learn this data set, I just remember this data set. However, if I have another data set which is outside of this 5, okay, which is outside of this 5, I don't quite know what's that. Okay, so that's what happened in the overfitting overfitting situations. On the other side, the underfit is if I have this 5 data, if I learn something and still knowing only 3 of these and didn't know about the 2 of those, okay, so it's kind of like a situation. I'm still remembering only small amount of data or small amount of knowledge on our data. Okay, so that's what happened in the overfit and underfit. So the overfit is I'm too much learn these things and ignoring some things. However, for the underfitting situation is I haven't learned the whole things. Okay, I still learn some of our training data and still haven't find another data. Okay, so when we applied our knowledge to our new data, which is outside of this data, both overfit and underfit can lead to a larger error to our unknown data. Okay, this is the training. Meanwhile, this one is for the testing. Okay, what's the common mistake that can make our model overfit for or the underfit? Well, I think normally the common mistake is since the splitting between testing and the training data is not representative, I think. Yeah. For example, like when you do splitting, selecting only on the positive one, ignoring the negative one, it will lead to the overfitting situations. Okay, make sure that if you have a certain distribution of positive values, positive label and negative labels, make sure that the negative and positive label exist in the training set. Therefore, if you apply your model to the unknown data, it will adapt to the unknown data as well. So it will avoid the overfitting. Meanwhile, for the underfitting, I think we can what is it add a more training iterations. For example, like in the artificial neural network, there are terminology, epoch terminology, which is we learn one cycle, another cycle, that's two epoch, another cycle, that's three epoch, and so on. So if you do with the underfitting, then make sure that you can add another epoch. And I think it's a really complex thing to answer only on using a discussion. I think it's better for you to practice for later on. I think that's my answer, Mas Budi. Hope that answers your questions. Okay, for Mas Abioso, I think I have already answered your questions. Yes, in TensorFlow we have we can use the scikit-learn as well. So you can use a cross-fault validation in there. I think cross-fault validation is a good way to avoid the overfitting or the underfitting, since we divide our data set in randomly chosen data for training set as well as the test set in there, and we learn our data based on what we know, and we compare in one fold to another fold. That will also avoid the overfittings. Well, we can provide validation data, to be honest, validation data that's will determine whether our model is overfit or underfit. Yeah. Okay, so coming from Mas Budi, is there any include encoder inside the TensorFlow? I think we already seen it, Mas Budi. Yes, in TensorFlow we have a collection of operations which we can encode some things. You can also add another operation, for example, like word to fact operation that I have already mentioned there before. Coming from Mbak Kurnia Octaviani, why when doing binary classification, the neuron in the output layer just one, but when doing multi-class classification, the number of neuron in the output layers equal to the number of classes? Okay, good questions. Binary classification, I think if you use binary classification, to be honest, you can also use two neuron as the output layer in the output layers. Why? Since on the output layers, you can say that, okay, I have probability of this one as the first class, that one as the second class. Okay, you can use it as well. However, for the binary classifications, what we need to predict is only positive or not positive. So if it exists in the positive or it's detected as positive, so the other class will be only negative. There is no other class. Therefore, in the binary classification, normally what people do is just put one in the output layers in there. I think that's my answer about Kurnia. Yeah. Okay. Hopefully it's answer your question. And then the next one coming from Mas Calvin Marcelino. Okay. If our model is overfit, how can we decide what method or adjustment we should use to fix that? How to know? To be honest, there are some methodology that we can use in the deep learning. The overfitting can arise to the number of training example, which is if we have low training examples, then we only learn on those small amount of data. Okay, when you deal with deep learning, you need to have a lot of data. Okay, well, to overcome the overfitting, you can add another data. However, if to obtain the data is very difficult, okay, there are some operations, for example, like the augmentation operations. Okay, you can flip image, you can rotate image, or you can zoom out or zoom in those images or crop those images That's another methodology for avoiding the overfitting. As well as there are also another technique which is called as dropout, which is randomly ignore some weight set with zero values, so it will ignore temporarily. Okay, temporarily ignore on specific weight, randomly chosen weight, and then learn on the other features. Okay, that's what happened to avoid the overfittings. Another one, however, the main goal to learn something is to find the best model, or the best knowledge that we have, even though it's architecture or the weights in there, weight combination in there. Well, to avoid these things, you can use always split your data into three type of data. The first is the training set. The second one is the test set. That's normally what people do. However, the third one is the validation set. The validation set in here to check whether our model is already in overfitting or in underfittings conditions. I think for during this demonstration session, I can give it the illustration for later on. That's the way how to know the overfitting exists or not exists. Okay, when we are overfit, sometimes when we learn something, the error will be, the accuracy will be increased. Okay, so based on the training set, it will increase. Based on the validation, it will also increase. However, at some point, if we find a situation where the validation set is dropped at certain epoch, then at those conditions, we will say that we already have an overfit conditions. So what we deal with it is we cannot adjust those things. What we can do is just roll back to our previous operations. So the best performance of the validation epoch, you can use that as your final model. That's my answer, Mas Calvin Marcelino. And then I think this is the last one before I go to the sharing session. When creating a convolutional neural network, how do we determine the optimal layer amount? It's a hard question, Mbak Alin. Yeah, coming from Mbak Alin. To be honest, myself, I'm unable to determine how many amount of layers that do we require to a certain data. Okay, so what we can do is if you would like to go there, learn how to create an architectures. Also, what is it? Make sure that you understand the characteristic. If you add a layer, if you add a convolutional layer, or if you add a pooling layer, or if you discard a layers, what is the effect on our classification models? Well, to be honest, I gave up for this question, since I don't have enough or sufficient knowledge about it. So I will ask this question as an open question. Also, when we are creating a convolutional layer, where we are asked to give the number of convolution as the first parameter, how do we determine the optimal convolution number for each convolutional layers? Okay, so this question also similar to the previous question coming from Mbak Alin. It's very hard question. However, the number of convolution in there are similar to an operation. Let me go back to the convolutional operations. Okay, these operations. So what do you expect from a convolutional operations? Well, as I mentioned before, this operation is an operation to a specific features. Okay, so if I create different features, for example, like all one, all zero, all minus one, it will affect different features. And then if I create all this is one, this is zero, this is minus one, this is zero, this is one, that's also represent something different. Okay, in an image, normally what we would like to have is a vertical line, horizontal line, diagonal line, left diagonal line, right diagonal line, the X, the O, and such filters. Okay, so normally, if we can see that, okay, since these situations need those kind of features, we can calculate or approximate how many numbers of filters that we have. However, still, even though we can imagine those kind of things in the applications, it will be difficult for us to determine how many numbers in there. Okay, so I think that's my answer for now on. Do I still have time in here, Mbak Bila? Okay.
Yes, we
Okay.
have 18 minutes again.
18 minutes. Okay, 18 minutes to go. Let me go to the what is it? The sharing session. The sharing session in here, I can copy this answers. It's provided by Bangkit to that's the code that we have for today, and as well as for later on, I will create a demonstration on different area, which is the transfer learning. Okay, so. I think I already have it in here. Okay, so the first demonstration is the simple convolutional neural network. Okay, the simple convolutional neural network, as Mbak Bila said, that we need to define how many convolutional operations in there. Yes, to create a convolutional neural network, you can easily import your TensorFlow in here, and then you can also use Keras. There are a bunch of libraries that you can use. For example, like you can use a dataset library and then layers, and then create a model, or using the specific optimizers. And then in these examples, we use the CFAR datasets, which include around 6,000 images in each class. So we have 10 classes in here. So it's provided by Toronto University, and you can download this data set, and then the data set in there is the airplane, automobile, bird, cat, deers, fox, dogs, and so on. I think while I'm explaining the code in here, I can run the data. As you can see before, there exists an airplane, horse, dog, and so on. So that's our class names, as well as our training dataset. Okay, so we have this dataset paired with its class label, and then what we do in our CNN here is we can create a models which coming from sequential. Sequential in here means we will have the first layer is the convolutional layers, and then the second layer is the max pooling layers, followed by the convolutional layers, followed by the max pooling layers. You can also change into the average layer, and then continue with convolutional layer. Without using max pooling, we can use flattened layers in there, and then put a neural network layer in here. Since we have 10 classes, as Mbak Alin question, or I forgot whose question is there. We need to determine how many output that we have in our last layers. Okay, we use softmax there. And then after we create or define the models, we can compile our model using some optimizers. For example, like you can use Adam optimizer or stochastic gradient descent optimizers or another optimizers. And then you will use accuracy metrics in there. When you use metric accuracy, normally we need to have an increasement of accuracy compared to its epoch in there. This is the model summary as mentioned on the model creation, and then this is the calculation, the accuracy calculations. Oh, okay. It's sorry to say, it's still a very long time to what is it to run this this code, and then in the end you will see the accuracy, the training accuracy as well as the validation accuracy. What is it? Melihat when you see the accuracy as well as the validation accuracy, you can have a sense that your model already in an overfitting or in an underfitting. If you are in an underfitting, that's easy. You just rerun again your model using the same data to increase your accuracy. However, if you obtain the overfitting, not the underfitting, the overfitting, then you need to roll back your models. Therefore, I will suggest you to store the knowledge during your training iterations. Okay, don't just run those fit operation without storing your model or your weight in there. You can roll back by loading your specific model that mentioning in your accuracy plot here. Okay, so let me ignore these things and then I will go to my I think I haven't put it in there. Let me copy another code, which is I made it myself. No, I didn't make it myself. I copied and pasted a couple of code coming from the internet. However, using this data, using those code, I have using the last one, I demonstrate transfer learning. So what is a transfer learning? Transfer learning is using people's pre-trained model. Okay, there are a couple of architectures that you can use. It's very best architectures, and you can use that as to create a feature extraction or fine-tune your model. Okay, so basically what we can do is after people learning something which need a lot of data, a lot of computational costs, and then their model is saved into a model, you can use those model. People already publish those model. And then what you need to do is just put your data in there, put your own domain. If you have a different data set, then just create your own data set. Okay, create your own domain, load your data set, and then train your network using the already proven architectures. And then without having the last layers on the previous architectures, and you can add another dense layer, which is the artificial neural network layers in there, and then retrain your dense layers. What you do in here is only training the additional layers. That's all. And in here, I have already created my own data set, which is on ILT 4. Sorry, I think I need to share my dataset. If you would like to playing around with my dataset, that's fine. Okay. Okay, so this is a dataset. In this dataset, I have the training as well as the testing one. For the training, in here I have 4 classes. The first one is the Adelia. I use the Aglonema flowers, Aglonema plants, namely Aglonema Adelia. I Google it, to be honest, Aglonema Adelia, and took the images in there and then created as my dataset. And then I have legacy, which is different from the previous Aglonema using lipstick. It's also different with the previous Aglonema, and part of Sumatra, which is also different with the previous Aglonema. So in my code in here, sorry, the first one is not that one. So I have the training set and then the validation set. Okay, I list the directory as the class name. Okay, so using that class name, and then what I'm doing in here is load the training set, load the test set. I'm not using validation set in here. I just use I just divide my data into two things, the training set and the test set in there. And then using the class name, I create a model which is load from the previously known models, which is I use ResNet 40 in here as my baseline. Okay, and then make my model trainable become false, which means that I already believe ResNet models. I didn't need to change the ResNet weight and so on. Therefore, I just use those output as features in my domain adaptations. Okay. Okay, I'm not a robot. Yes. Oh, okay. Traffic light. Sorry. Okay. So and then I create an input. I create what is it? I pre-process the input in the pre-process using some pre-processing techniques, such as what is it? There is an augmentation and so on, and then put it into my model after the input itself become pre-processed, and then adding the base model as our first layers, even though it's the first layer. However, it's still what is it? Appears a couple of layers in there, which is obtained from ResNet models, and then put global average, flatten, dropout, and so on. And then what is it? I define how many classes that I have. It's obtained from the previous operation, and then what is it? Create the model, and what is it? Compile the model, and then last one, I fit or train the model itself, and then I obtain the one that the performance measure that I use in here is the loss, not the accuracy. Since I'm using the loss, then the loss should be increased day after day, or the iteration coming to the next iterations, and then using that models that I already trained in here, I classified. I load the what is it? The testing dataset, and classified this image coming from the original class is equal to Adelia, and classified as Adelia. And as we can see in here, I have a couple of misclassification coming from the original class is legacy. However, it's predicted as legacy only on a couple of rows in there. And then for lipstick, it's better compared to the legacy, and Pride of Sumatra, it's much better compared to the previous one. So basically, using this kind of technique, it saves our time, to be honest, since we use previously known architecture, which need a lot of data, a lot of computational costs, and so on. So what you can do in here is just create a domain adaptation and then put your experiment in there. I already put my code in the chat column as well as the data set as well. Hopefully you can change my code into your own data set. Okay, what shall we do now, Mbak Bila? What time is it? We still have 6 minutes, I think. Yeah. Okay.
Yes, Mas. We still have couple.
Okay, thank you, Mas Jafar. We still have 4 minutes. We still have an open question. Hopefully, I can answer a couple of questions. When I see evaluation matrix, it's coming from Mas Muhammad Zidni. When I see evaluation metric on transfer learning model that usually use data annotation using the mean average precision, why use evaluation metric instead of others? And what are the advantage of mean average precision? Okay, so the mean average precision, it's kind of like you use the precision. Okay, use the precision rather than using the error or those kind of things. So basically, when using the performance measurement, you need to know what kind of task that you deals with. If you are using the classifications, you can use the precision pace or the prediction pace performance. Sorry, I just scanned my slide and find out which one. Okay, so this is the evaluation metric for the classifications. To be honest, when you use the precision as well as the accuracy, it's almost similar. It's almost similar. However, there are differences between precision and accuracy. Okay, so in positive, in the average precision, what you deals with is the positive one. Let's say let me recall the formula for the precision itself. The precision is the true positive compared to the true positive versus the false negative. It means that you only aware on the actual positive classes. Okay, if you deals with for example like a COVID test, okay, it's really important to know that for every positive values to be detected rather than using the accuracy. We don't we are not aware about the negative one, to be honest. Since why? Since for the positive one, if it's detected into a negative one, it's become disaster for our community. Okay, that's why you will use the average precision. Is it only for the disease? Only for disease? No, the answer is not like that. The answer can be another things. For example, like, okay, in my area, in orchid area, there are a specific species which is endangered or not endangered. If I would like to predict that things, the most valuable thing is the one which is endangered. So I can use precision to to create a good models in there. So it's depend on our case, to be honest, Mas Sydney. If we didn't need to be aware about which classes or specific classes, then accuracy is better. If we need to be aware only on the specific classes, then precision are better. Okay, I think that's my answers. And as well as if you deals with the regression, don't use the classification matrix for your performance metrics. Okay, you are very welcome, Mas. And then the second one coming from Luis Michael, considering the drawback of max pooling on bright pictures. Okay, with many high value pixel and average pooling on dark pictures with many low value pixels, would we consider the best pooling type for the model based on the use case? Or is there any other better alternative for getting a better model? Well, I don't have any sufficient experience to answer this question. However, I will give you a clue, Mas. To be honest, the values on our filtering operation, on the convolutional operation, our filter values in the convolutional operations, not always 1. It can be -1. Okay, so considering that things, still max pooling can be useful, yeah, especially to detect a kind of specific features. However, we need to, based on my small amount of experience, I think we need to do a lot of experiments to know that phenomena. I do apologize. I cannot answer your question, since it's also hard for us to decide what kind of operations, how many layers, how many number of convolution that we have, how many deep, and so on. It's also difficult for us. I don't have sufficient knowledge for it, and well, we can read later on. Yeah, I think that's the whole question in question and answer. Do I answer all question? I think I've already answered the whole question, right? And it's also more than 11, so I think thank you very much for your attention. I do apologize for another additional 3 minutes on this talk, and still I didn't discuss about the other sharing session. Hopefully you can try in your home. Thank you very much, and thank you. Yeah. Okay. Thank you very much. I gave the time to Mbak Bila and Mas Jafar.
Okay, Mas Agung, thank you for delivering the session. And I think this is the end of our ILT class. For cohort, don't forget to fill out the feedback form that attached in your calendar. And good morning, guys. Thank you.
Okay, good morning all. Thank you very much for a fruitful discussion. Bye.
Thank you, sir.